Hey everyone. I'm kind of bummed. I was gonna open with a song again, but last time YouTube copyrighted my video and blocked it in some countries, so I just don't want to make a fuss about it, and we'll just get into the video, I guess. But anyway, we're gonna do 9.5, the dot product. And again, we're just going, this is like multiplying. The dot product is you just like multiplying them. So you're going to multiply the i's together and the j's together. So the first one here, we have v, vector v times vector w. So we have 2. Make this smaller. So 2 times 5i. And then when you're doing this, we get rid of the i's. So just 2 times 5, because we're following this equation here. And then plus b1 times b2. And we can label these. And then b1 would be negative 3. And then b2 is 3. So 2 times 5 is 10. And then negative 3 times 3 is negative 9. And then 10 minus 9 equals 1. And that's it. For b, we're doing w times v. So we did v times w. Now we're doing w times v. So now w comes first. So 5 times 2 plus 3 times negative 3. So 5 times 2 is 10. 3 times negative 3 is negative 9. 10 minus 9 is 1. Next, we have v times v. And as you noticed, in A and B, they were both the same answer. And that's because when you're multiplying, you can swap the two places and it still comes out the same answer. So in C, we're doing v times v. So 2 times 2 plus negative 3 times negative 3. And that equals 4 plus 9, which equals 13. Next is w times w. So 5 times 5 plus 3 times 3, which equals 25 plus 9, which is 34. All right, now we're doing the magnitude again, and we have that magnitude formula from the 9.4 notes, and as we can recall, that equals a1 squared plus b1 squared. So let's do v, a equals 2, b equals negative 3. Plug those values in. We get 2 squared plus negative 3 squared, which is 4 plus 9, which equals the square root of 13. And then we're going to do the magnitude of w. So a equals 5, b equals 3. So the square root of 5 squared plus 3 squared, we get 25 plus 9, which equals the square root of 34. As you're seeing, you're just plugging in the dot product into that square root, and that's what the magnitude is for a vector. And it's the dot product of multiplying itself together. Okay. Next, we're going to use the properties of the dot product. So as we noticed from A and B, it's commutative. So u times v is the same thing as v times u. Then we can also use the distributive property of the dot product, that if we are multiplying u times something, you can distribute that u into the parentheses, that vector. And then we also have these other properties that we can go and use. And then the angle between two vectors we can find using this formula. So we are going to find the angle between u and v given. So first we have to do the dot product of u times v, because that's the numerator. So u times v. So again, the i's multiply. So 4 times 2 plus negative 3 times 5. And then I'm going to label this u times v. So that equals 4 times 2 is 8 plus negative 15. Which equals negative 7. Now I'm going to do the magnitude of u. So magnitude of u. And we do that by the dot product of u times u. So 4 times 4 plus negative 3 times negative 3. And that equals 16 plus 9. And then 16 plus 9 is 25. And then you plug that in the square root. So the square root of 25 equals 5. And then we can do v. And I'm going to use the magnitude formula this time of the square root of a1 squared plus b1 squared. So 2 squared plus 5 squared, which equals 4 plus 25 square root, which is the square root of 29. And now I'm going to plug all those values in into that formula. So we have cosine theta equals negative 7 plus 25 over 5 times the square root of 29. Oh wait, the dot product of u times v is just negative 7. So negative, I knew I was doing something wrong. Okay, so negative 7 over 5 root 29. And then to find out what theta is, we're going to multiply both sides by the cosine inverse. So then we get theta equals cosine inverse of negative 7 over 5 square root 29. And here we just plug this into our calculator. So theta equals 105 degrees. All right. Now we're on the last one. So, and here's where we're talking about orthogonal vectors. And vectors are called orthogonal or perpendicular when the angle between them is 90 degrees. And that makes sense because perpendicular lines create a 90 degree, like this. 90 degree perpendicular lines. So vectors are orthogonal when their dot product equals 0. So we're going to determine if v and w here in this example are orthogonal. So we just need to do the dot product. So we're going to do v times w. And we're just going to apply the formula. So 2 times 3 plus negative 1 times 6. So that's 6 plus negative 6, which equals 0. So since it did equal 0, therefore, which you can write using these 3 dots, v and w are orthogonal. And as promised, we're not going to go do that word problem. All right, let me know if you have any questions.